Hello friends, I am Anjuna. Welcome to my class. Students, in previous video we have discussed about measurement. In this video we will learn about standard units of measurement and motion. Let's learn about standard units of measurement. Children, we already discussed about the measurement, but again we will revise. The standard unit of length is meter. Scientists all over the world use meter as the standard unit. By the International System of Units means SI units, meter has been accepted as the standard unit of measurement for length. So we can say that the SI unit of length is meter. Standard units bring about uniformity in values and do not vary from person to person or from place to place. Children, you can express the height of a tree or the length and breadth of a room in meters. But if you want to measure the length of a book or your pencil box, you will need a unit smaller than a meter called centimeter, expressed by the cm, small letters. The word centi means 100th. This means that there are 100 centimeters in 1 meter. Okay? Most small things, such as the thickness of a coin or the length of a rice grain, are measured by a unit smaller than centimeter. It is called millimeter. Okay, express small mm. Milli means 1000. There are therefore 1000 millimeters in 1 meter. How many millimeters are there in 1 centimeter? Count the number of millimeter in 1 centimeter on your scale. Okay? आप ये स्केल देखिए और इस स्केल में आप 0 से 1 ये डिस्टेंस होता है 1 सेंटीमीटर का. अब इसके बाद आप 0 के बाद जो स्मॉल लाइन है वहां से काउंट करिए 1 तक. आप देखेंगे कि 0 के बाद जो फर्स्ट लाइन है वहां से 1 तक 10 लाइन्स होती हैं और ये 10 लाइन शो करती हैं कि 1 सेंटीमीटर में 10 millimeter होते हैं. Okay? To measure the distance between two places, say your school and your home, you have used a unit larger than a meter called kilometer. Kilo means 1,000 times. So, how many meters make a kilometer? Yes, 1,000 meters make a kilometer. We can sum up all that we have learned as follow. 1 kilometer equals to 1,000 meter. 1 meter equals to 100 centimeter. And 1 centimeter equals to 10 millimeter. अब अगर हम स्मॉल यूनिट को लार्जर यूनिट में कन्वर्ट करते हैं तब हमें डिवाइड करना पड़ता. ओके, लाइक 1 मीटर इक्वल्स टू 1 upon 1000 kilometer and 1 centimeter 1 upon 100 meter and 1 millimeter 1 upon 10 centimeter. और अगर हम इसे मीटर में कन्वर्ट करते हैं तो 1 upon 1000 meter. Let's learn about motion. Children, what do you observe when you go out? You find many objects moving around you. You find cars, buses, trucks, and bicycles moving on the road. All these objects are changing their position with time. So, when an object changes its position with time, it is said to be in motion. An object that does not change its position with time is said to be at rest. The object may have slow or fast motion. For example, the motion of a snail is slow as compared to a moving ant. Okay? To know how fast or slow the motion of an object is, we need to measure the distance traveled with respect to time. That is, the distance traveled by the object and the time taken to travel this distance. Okay? Rest and motion, the states of an object. Children, if you look around, you will find different objects in different states. These objects are either at rest or in motion. For example, your house, furniture in the house, schools, trees, electric poles, post office, railway station, etc. are at rest. But people walking on a road, moving vehicles, flying birds, falling raindrops, crawling insects, rustling leaves, etc., are in a state of motion. You know, children, rest and motion are relative terms. Okay, we understand now. For defining the term rest and motion, we need some surroundings. Okay, an object may be at rest with respect to one reference object and in motion with respect to another. Suppose you are sitting in a moving train. Okay, if you compare your state in relation to the other passengers, okay, or wall of the train, you are at rest, you are not moving, but in relation to the objects outside the moving train, such as trees, road, rivers, bridge, etc., you are in motion. Okay, mostly we consider the motion of the objects with respect to the earth. Your house is at rest with respect to the earth, but the earth is continuously moving around the sun. It means that your house is also in motion along with the earth around the sun. Thus, rest and motion are relative terms. Let's learn about types of motion. Okay? Think of some moving objects like the arms of a watch, the blades of a fan, the pendulum of a wall clock, and leaves of a tree while the wind blows. Though all these objects are moving, their movement is not the same as that of a running child or a moving car. How do they differ? To understand this, let us now different types of motion. First is translatory motion. Children, if a body moves on the whole from one place to another, so that all its body parts move the same distance in a given time, it is said to be in a translatory motion. Okay, translatory motion is of two types: rectilinear motion and curvilinear motion. What is rectilinear motion? Students, when an object on a whole moves along a straight path, it is said to be in rectilinear motion. Okay? Examples: rectilinear motion, a ball rolling on a flat ground, an apple falling from a tree, water flowing from a tap, okay, car moving on a straight road. That's showing rectilinear motion. Next is curvilinear motion. When an object on a whole moves along a curved path, it is said to be in curvilinear motion. You understand by the example, like a train taking a curved path in a hill station. Okay, and dolphin taking a dive, a ball coming down after being thrown up at an angle, and car moving on a curved road, these showing curvilinear motion. Next is circular motion. Recall the motion of the arm of a watch, blades of a fan, a giant wheel, and the planets around the sun. Children, they all move around a fixed point on a circular path. When an object moves around a fixed point on a circular path, it is said to be a circular motion. Circular motion is also of two types: rotatory motion and revolutionary motion. Let's learn about rotatory motion. Children, when an object does not change its position on the whole from one place to another, it is said to be in rotation or rotatory motion. For example, blades of a moving fan. Another examples, arms of a watch, a giant wheel, etc. They show rotatory motion. Let's learn about revolutionary motion. When an object moving on a circular path changes its position on the whole from one place to another, it is said to be in revolution or revolutionary motion. For example, planets moving around the sun and the moon moving around the earth show revolutionary motion. Let's learn about oscillatory motion. Children, when you sit on a swing and after you push the swing backward with your foot once, you come back and go forward. Such a motion in which an object moves to and fro about a central or mean position is called an oscillatory motion. Other examples of such motion are the pendulum of a wall clock and the motion of a sieving machine needle, movement of a seesaw, etc. Very fast oscillations are called vibration. Children, vibration is also an oscillatory motion when an object moves to and fro, and initial applications of force allow an object to vibrate freely. However, the vibration slows down and finally comes to a zero. A string of a guitar vibrates when plucked. Our vocal cords vibrate when we speak. A tuning fork vibrates when beaten. Our eardrum vibrates when a sound reaches it. Okay? Let's learn about periodic and non-periodic motions. Children, we know the earth completes its one rotation in 24 hours and one revolution in 365.25 days, while the pendulum of a clock complete one oscillation in 1 second. The motion of these objects repeat after a fixed interval of time. Such motions are called periodic motion. Okay, let's learn again. A motion which repeats itself after a fixed interval of time is said to be periodic. Motion that is not periodic is known as non-periodic motion. In this type of motion, the object may be repeating the movement but not at regular interval of time. For example, When you swing your arms while walking, the action is repeated, but it is not same each time. Our heartbeat and the movement of the lungs during breathing are repetitive but not exactly periodic and are considered non-periodic motion. Let's learn about random motion. Children, observe an ant moving or a butterfly flying. Their motions are a combination of all the above type. Such motions are called random motion. There is no fixed type of the movement in the moving objects. Let's learn about multiple motions. Sometimes an object shows two or more types of motions simultaneously. Such an object is said to have multiple motions. For example, a moving car has translatory motion as a whole, but its wheels show rotatory motion. Okay, consider an example of a rolling ball. Okay, when the ball moves from position A toward position B, it is in translatory motion. At the same time, it is also rolling about its center point axis, which shows that it is in rotatory motion too. Some other examples of multiple motions are the motion of the earth on its axis, rotatory motion around the sun, revolutionary motion. A drill machine, while using, has both translatory, means rectilinear, as well as rotatory motion. Understand? Okay. Now, this video is finished. I hope you all understand. Thank you.